Hello everyone. In this video I'm going to show how you can do binning with R. We will use again customers data. The manager for this store would like to perform the RFM analysis. RFM is a popular marketing technique which is used to identify high-value customers. RFM stands for recency, frequency, and monetary. The RFM ratings can be created from days since last, which represents recency, number of orders, which represents frequency, and spending 2018, which represents monetary. Following the 80-20 business rule, which says 80% of your business comes from 20% of your best customers, for each of the three RFM variables, the manager would like to bin customers into 5 equal size groups, with 20% of the customers included in each group. Each group is also assigned a score from 1 to 5, with 5 being the highest. Customers with the RFM rating of 555 are considered the most valuable customers to the company. In addition to the RFM binning, the manager would like to bin the income variable into 5 equal intervals. Finally, the manager would like to start a tiered membership status where different services and rewards are offered to customers depending on how much they spent in 2018. She would like to assign the bronze membership status to customers who spend less than $250, silver membership status to those who spend $250 or more but less than $1,000, and the gold membership status to those who spend $1,000 or more. So we will use R to bin variables according to the manager's specifications. So the first thing we will do is we open R and then open a new R script. The first thing is we need to set our working directory, choose our directory, and since all my files are under R videos, I will use R videos as my directory. I click on it, and then under files, you can be able to see the customers.csv file. And then we are going to import this customers.csv file as a new data frame, which is called my data. So what we are going to do is we type my data is equal to read.csv is importing the CSV files. And now we need to tell R which file we want to import, which is customers.csv. And then Control Enter. Now we can be able to see here under Environment pane 200 observations and 14 variables we have. To create the recency score, we need to first transform the variable days since last to reverse the order of the data, because the fewer the number of days since the last purchase, the greater is the recency score. So we are going to create a new column with the column heading days since last reverse with R. In order to create a new variable called days since last reverse, we will multiply days since last variable by -1. And we use the as.numeric function to ensure that the days since last reverse variable is a numerical type. So we will type here my data, and then we need to select the column, or we are going to tell R that this is going to be the column, and the name of the column is going to be days since last reverse is equal to as.numeric. We are going to choose my data days since last column, and then we multiply this column by -1. This is going to be my new column on my data frame. So after you type this command, Control Enter, and under Environment, my data now have 15 variables. Let's check. And here we have a new column called days since last reverse, and all the numbers are negative as you see on the screen. We now create 5 equal size bins for days since last reverse, which represents our recency, number of orders, which represents frequency, and spending 2018, which represents monetary. As the bins represent the 20%, 40%, 60%, 80%, and 100% quantiles, we first use the quantile function to find a range for each bin and store, and then view the ranges in an object called recency bins. So what we need to do here is we are going to create a new object called recency bins, and that's going to be equal to quantile function. The quantile function divides the data into 5 percentages, and in quantile you are going to tell again R which column, we need to apply this function, which in this case days since last reverse column. And also we will use here prop is equal to seq sequence function, and inside the sequence function it starts from 0 and it goes until 1, and it should go by 0.2 or 20% incremental. Okay, that's why we use this. We forget the comma here, so you have to be careful with your coding. You need to make sure you have commas where there needs to be. And after you finish that, you control enter, and now you have a new recency beans object. So let's see this object, recency beans, and then enter. And you can see that here we have 5 equal size beans on the console. We repeat the similar commands for the number of orders, frequency beans, and spending 2018 monetary beans variables. So let's write for frequency, or we can just copy paste this. But now we are going to change a couple things, right? So instead of recency here, this is going to be frequency. Frequency beans, and this time I'm going to choose the relevant variable. Frequency is measured by number of orders, so I'm going to choose number of orders column. Here I want to see again frequency beans, and then you can select both, control enter. So you see frequency beans is created under values. And now the last one is for monetary beans. We again copy paste this, and now we are going to change here to monetary, and then this one needs to be spending 2018, and then this needs to be again monetary. And again you select both and then control enter. So you see monetary beans is created. We use the cut function to bin the data. First let me write the code to bin these variables, and then after that I will explain the options. So here to bin recency, I'm going to create my data, and then I'm creating a new column called recency is equal to, I will use cut function to bin the data. And which data I want to bin, I need to select from my data frame, and I want to bin days since last reverse, and the breaks option of the count function specifies the ranges of the bins created in the previous step. So our breaks are going to be recency bins, and then comma, and we use the labels. Labels option assigns a label to each bin, and now we want to label all bins. As we talk about it, RFM is lowest 1, highest 5. So it is composed of 1 for the first quantile, and then 2 for the second, and then 3, and then 4. But do not forget the commas in between. And then 5. And next we are going to include that lowest option. Include that lowest is going to be true. So what does this option do? This option must be used along with the right is equal to false option, so that the largest value is included in the last bin. So we need to also include here right is equal to false. So why do we use this right is equal to false option? Because the right is equal to false option ensures that the intervals are closed on the left and open on the right. And include lowest is equal to true option must be used along with this option, so that the largest value is included in the last bin. So we completed this code, and now let's run it. And you see, let's go to my data now, and there is a new column called recency, and as you see it is composed of numbers from 1 to 5. And we will copy paste this, and we'll do the same thing for monetary and frequency. For frequency we are going to change here to frequency, And the data needs to be different here too. We are going to select this time number of orders. And the beans are going to be frequency beans. Labels are the same, 1, 2, 3, 4, 5. And also we need to include dot lowest option and right is equal to false option. Now it's ready. Control Enter. Now let's look at our data. Now as you see, we have a frequency variable in the data. And let's do that for the monetary. And here this time our variable is spending 2018 and breaks are going to be monetary beans and labels are the same, and then Control Enter. So we have all the variables now, as you see here, recency, frequency and monetary. The next step is we are going to combine all these recency, monetary and frequency into one variable called RFM. So to create RFM score, we combine the three RFM indices using the paste function and then use the head function to view the first few observations. So here my data, I'm going to create a new column in my data frame and call it RFM is equal to paste. So what I'm going to paste? I'm going to paste my data recency and then my data frequency and finally my data monetary, and then Control Enter. Now we have a new variable called RFM here. You see RFM, the new variable, and we can use head function, but we need to make sure which data frame we are referring to see the few observations from this variable. You see the first one is 411, the second one is 244, the third one is 433. The next step is we are going to bin the income variable into 5 groups with equal intervals using the cut function. The breaks option in the cut function specifies 5 bins with equal intervals. We assign numbers 1 representing lowest to 5 highest to the bins and then use the head function to view the first few observations. So we are going to create my data, a new variable called binned income, and that is equal to cut function, which variable I'm going to bin, my data income, and now I want 5 categories, and then the labels are going to be starting from 1 representing lowest, 2, 3, 4, 5. And again we are going to use include dot lowest, true, and right is equal to false. False needs to be uppercase. And now Control Enter. So we have created a binned income. We can see it on our data set here, binned income, which is composed of numbers. Next, we use the levels and cut function to display the ranges of the 5 intervals created previously. So we are going to type labels, cut, my data, income, breaks is equal to 5, and then Control Enter. And as you see that the first interval is 30,900 up to 58,200. To find out the number of observations that belong to each bin, we use the table function, table, my data, and I'm going to select binned income and then Control Enter. So the first category represents the lowest income customers, which they have 67 customers in it. To create the membership tiers or user-defined bins proposed by the manager, we again use the cut function. Recall that customers who spend less than $250 are assigned to the bronze membership. Those who spend $250 or more but less than 1,000 receive the silver membership, and those who spend 1,000 or more receive the gold membership. We use the breaks option to specify user-defined ranges. So we are going to use a very similar code like this one. So here my data $bin income. This time we are going to call our new variable membership tier, and we cut here not the income, spending in 2018. And for breaks we have user defined breaks, so we will use C, which represents the vector in R, 0, 250, 1000, and inf. Inf assigns any values above 1000 to the last bin. That's why we include inf here. And the labels are going to be different too. The first one is going to be bronze, second one is going to be silver, and the third one is going to be gold. We don't have 4 and 5, so we are going to delete this one. We don't need to use include.lowest or right option. So this is our code, control enter. Now we have 21 variables. Let's go see my data. And now you see the membership tiers are assigned to each customer based on their income level. So this is all about how you use R to bin the data. I hope this video is helpful, and thank you for watching.